Good morning. So we've been talking about solving quadratic equations. And if we look here, we know the quadratic formula can solve any equation. But what if the equation's not in standard form, if terms are missing, things like that? There's other methods to solve. Some of our methods that we know are, obviously quadratic formula, completing the square. I guess I'll write it like this, completing the square. We know the zero product property. We know perfect squares, difference of perfect squares. Okay. So we have all these different methods, and the problem we're going to get into now is, like, how do we know what method is the best? So when we look here, I can try this one. I can do the quadratic formula, but I'm going to see if I can factor it. Factoring is pretty easy. So I'm going to just set this up, x squared and 27, and then that becomes 27x squared and 12x. Can I think of numbers that multiply to 27 and add to 12? Well, 9x and 3x is the first thing that pops into my mind. And then that means I can just set this up. So we always like to do the x's first, x and x. That works out really nice. And then x times what makes 3, x times what makes 9, and luckily 9 times 3 makes 27. So this becomes x plus 3 and x plus 9 equals 0. That's one way I can solve this problem. It's a different method. That's much easier than the quadratic formula, completing the square. I'm going to apply the zero product property. So I'm going to have x plus 3, set each of these equal to 0. Subtract 3 from both sides, you get x equals negative 3. Subtract 9 from both sides, you get x equals negative 9. So these are my two answers that I'm going to get for that problem. Okay. When I go down to part C, well, this is a very simple one to decide. I'm going to take each of these products, each of these terms, and the product of those terms makes 0. So I'm going to set up each one equal to 0 and solve. So we're usually doing the zero product property. So subtract 4 here, you're going to get 3x equals negative 4. Divide both sides by 3. I'm going to get x equals negative 4/3. There's one of my answers. And on this one, let's go ahead and solve it. Add 1 to both sides, you get 2x equals 1. Divide both sides by 2, x equals 1/2. Okay, zero product property. Let's look at the next couple. This is a tricky one. We should be able to notice that this is a difference of two perfect squares, 2x and 2x, and 11 times 11. If you don't notice it, I'm going to see if I can factor this. See how our box comes into play like almost everywhere where we go? So we're going to go right here, 4x squared and negative 121. I'm going to that's going to be really, really a big number. It's going to be 484. And what multiplies to 484 that I can get that out of? Let's see. I don't know. That's why we need to recognize the difference of two perfect squares. So I'm going to actually do this one, 2x plus 11, 2x minus 11 equals 0. So I could set this up like this, 2x plus 11 equals 0, 2x minus 11 equals 0. You can do that if you notice that that's a difference of two perfect squares. Let's go back to our little, let's see, what's 22 times 22? Oh, 484. Okay, how did I get that? Because I knew that 2 times 11 was 22. So I would go 22 and negative 22. 22 and negative 22. Let me show you where this comes from. We're going to go, what multiplies to make 4x? How about 2x and 2x? Then what multiplies 2x? 11 and negative 11. So see my factors here? But that 22 was hard to come by. I actually only thought of it after I wrote out this 2x plus 11, because I could see that they need to be multiplied together. I can solve each of these, and I get subtract 11, 2x equals negative 11, or x equals negative 11 halves, plus 11 plus 11, 2x equals 11, or x equals 11 positive, 11 halves positive. So this is a very, very powerful recognition right here that I have, it's a subtraction problem or a difference, and then this is a perfect square, 2x times 2x and 11 times 11. If you don't see that, we can always do the quadratic formula and let a equal 4, b equal 0, and c equal negative 121. You can always do that. But I'm showing you that if you can recognize this is much faster right here, just breaking it up to 2x plus 11 and 2x minus 11. We'll practice the quadratic formula when we get down to the bottom. Let's go to part D. Well, when I have to decide what I'm going to use for this strategy, first thing I need to do is I need to set it equal to 0. So I'm going to subtract 8x from both sides, and I'm going to add 4 to both sides. So I'm going to get x squared minus 8x plus 16 equals 0. And again, if I can factor stuff, factoring it makes it so nice. So we get x squared and 16. What numbers can you think of that give me, multiply to 16, that I can get a negative 8x out of? Well, negative 4x and negative 4x. Negative times a negative is a positive. Negative plus a negative is a bigger negative. So I'm choosing to factor here, and I'm going to get, let's see, x times times x, and then negative 4 and negative 4. So this is the same term, so I can write that as x minus 4 squared equals 0. Well, we've been practicing how to solve terms like this. We're going to take the square root of both sides. We can see since this is equal to 0, we're only going to have one solution. Remember, if it equals 0, it's one solution. So x minus 4, add 4 to both sides. Here we're going to get x equals 4. So I have one solution. Okay. So what are the methods I've done? Factoring, noticing that it's a difference of two perfect squares, the zero product property, and then factoring again. And this is a perfect trinomial square. Okay, but you don't have to remember those things if you can put this in the box. All right, let's look at this last one. Now again, remember we have to set equal to 0 to figure out what we're going to do. So 36x squared, subtract 60x from both sides, plus 25. Now this is a really complicated problem because the numbers are so big. So if I go to set this up, I'm going to have 36x squared. Oh, I see something. And 25 here. So I have 36 times 25 equals 900. Well, what multiplies to make 900? That also adds to negative 60. Well, I can see that this is a perfect trinomial square, but if I'm really stuck, maybe you can't see that, I can always do a equals 36, b equals negative 60, c equals 25. Again, those are really big numbers to put in my quadratic formula. But I do notice that this is a perfect square and this is a perfect square. So check this out. This is a perfect square of 6x times 6x. This is a perfect square of 5 times, oops, I should do 5 times 5. Does it work out? Are we going to get, if I get 30x here, make this a negative, because I have negative 60, and negative 30 here, negative 30 and negative 30 makes negative 60. Oh my goodness, this is going to work out to have 30 and 30. But I noticed that because my first term and my last term was a perfect square. So I can easily factor this as 6x minus 5 squared equals 0. Sorry, you need to see that. Take the square root of both sides. You're going to get 6x minus 5 equals 0. Add 5 to both sides. You get 6x equals 5, or x equals 5, 6, right? That's a kind of a big mess. But let's come over here. Let's do the quadratic formula. Negative b plus or minus the square root of b squared negative 60 squared minus 4 times 36 times 25, all divided by 2 times 36. This is where my calculator comes into play. Maybe I can type that all into Desmos, because that's what we're using, the Desmos calculator at home, right? So I'm going to switch over to Desmos. You can't see Desmos because I don't have the computer set up that way. Alright, let me pause. Alright, so since I don't have Desmos on the computer, what I did is I got this calculator so you can see I typed exactly what it was in. Negative 60 plus or minus negative 60 squared minus 4 times a is 36, c is 25, divided by 2 times a, and I got 0.83333. But remember, the answer was 5 divided by 6 when I did it the other way. And look at 5 divided by 6 when I put it in the calculator mode is 0.83333. So the same thing. So you can use a calculator, but this is a little bit more challenging, but it's very doable. You have to recognize what is the best format. I happen to notice that 36 and 25 were perfect squares, so I see if it works. 6 and 6, 5 times 5, and it did. Let's do this next problem here. Just subtract 2 here and subtract 45. So we get 20x squared minus 32x minus 45 equals 0. Because remember, our goal is to set everything to 0. And I don't see this one working out well. It's not a perfect square. Nothing's a perfect square. So now I'm going to go a equals 20, b equals negative 32, and c equals negative 45. And I'm going to go negative b, 32, minus the square root of negative 32 squared minus 4 times 20 times a times c, that negative 45, all divided by 2 times a, which is 20. Now I'm going to put this in the calculator. Okay, so when I put this in the calculator, or on Desmos, I can only put in a plus, so I should put plus or minus, but I can only put in a plus or a minus on a calculator at a time. So I'm going to get this problem, and I get 5 over 2 for one of my answers. 5 over 2. Then I'm going to do the same exact problem again, so this cool little feature, Control C for copy. Come down here, Control V. I know you do not have this calculator at home, but I'm just going to take this problem right here, change that to a minus, and now when I hit enter, I get negative 9/10. So those are my two answers, 5 halves and negative 9/10. Okay, so there's lots of methods to do this. Let's look at the next one. Okay, so do we use the quadratic formula or do we use completing the square? You have to decide which method is your most preferred. So let's look at quadratic formula. A equals 1, b equals 6, c equals 11. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this becomes negative 6 plus or minus the square root of 36 minus 44 all over 2. And I'm going to get negative 6 plus or minus the square root of negative 8 divided by 2. So now I'm going to have no real solution because that's a negative number right there. Let's see what happens when we complete the square on this problem. By completing the square, we're going to take x squared plus 6x equals negative 11. Remember opening up that space. I'm going to add half of this one squared, so plus 9, and I'm going to get x plus 3 squared equals negative 2. Take the square root of both sides. Oh, look you're going to get x plus 3 equals, and again, there's a negative number there, so no real solution. So I knew there was no real solution because that's a negative, and I know there's no real solution because this portion of the quadratic formula is negative, and if that's negative, then you know that you can't solve it. So these two right here, or these 3 problems down here, I'm going to have you guys work on them. I will work on them on Zoom with you on probably on Wednesday Zoom. And okay, I'll give you a hint. This is a perfect square, that's a perfect square. Solve for 0 and then choose what method.